Ceva proudly presents the first fully C-based optimizing toolchain for DSP applications. Thank you for joining us today. In this short video clip, you will see a live demonstration of the new Ceva Project Build Optimizer. The Project Build Optimizer is just one element of a complete optimization toolchain recently announced by Ceva. In the diagram below, you can see the various layers of the optimizing toolchain, starting from command line tools, graphical interface, integrated toolchain, and finally, the Ceva Application Optimizer that enables the process of software optimization in pure C-level. The Project Build Optimizer is able to build, simulate, and profile multiple application scenarios and achieves near-optimal results in C-level while matching the customer's precise application and system architecture. It does so by creating ready-to-use, near-optimal project configurations. The configurations are based on pure C-code compilations, freeing the programmer from having to use handwritten assembly, and the entire process is fully automatic. Let's begin by starting a new Project Build Optimizer session. First, I will supply the Build Optimizer with a list of all possible configurations that I want to take into account in the optimization process. I can simply add all different compiler options, libraries, user definitions, and basically any setting I might consider using during my development process. For each predefined configuration, the optimizer builds, simulates, and profiles one or more projects. The entire process is based on the customer's system conditions and test data. Traditionally, the application code is built and configured based on static source analysis, which does not take into account runtime conditions. The ability to automatically integrate profiler-based system-aware data over a very large set of options is what makes this process so valuable. Doing this entire process manually for a real application is virtually impossible. Once the Project Build Optimizer process has been completed, we'll see this large summary table. The table summarizes the application cycle count and code size for all the different options evaluated in the process. We move now to a graphical view in order to quickly analyze the results. In this graph, the red dots represent the performance results for each predefined configuration evaluated by the tool. The blue dots represent new configurations that were automatically created by the Project Build Optimizer, and this is done after analyzing the entire profile data of the predefined configurations. Different performances versus cost trade-offs trigger the Project Build Optimizer to recommend multiple new, near-optimal configurations, each with a different trade-off. The meeting point between cycle count and code size is the theoretical optimum we would like to achieve, representing the minimum possible cycle count and code size. The new generated configurations, represented by the blue dots, offer a huge performance gains over the basic configuration the programmer might have considered using. For example, in this project, we use the AMR-NB standard reference code on the Ceva X1622 Dual Mac DSP. Using out-of-the-box pure C-code compilation, this DSP requires only 19 MHz without any user intervention. This automatically achieved result can be further optimized using C-level optimizations, reaching 15 MHz for the same application and running on the same Dual Mac DSP. In contrast, a fully optimized handwritten assembly code would require 12.5 MHz. Finally, after selecting the preferred optimized configuration that best matches the customer's performance requirements and budget, the tool automatically generates a ready-to-use project configuration. If the performance satisfies the programmer's requirements, no further optimization is required. Alternatively, the programmer can now further optimize his project in C-level using the additional tools offered by the Ceva Application Optimizer. Ceva's Application Optimizer significantly reduces SoC development time and improves the performance of the customer's target application by more than 60%. For more details, please follow this link. Thank you for watching today's demonstration.